Welcome to Sravz technical series. In today's session, we will discuss Docker Swarm setup in a multi-node Ubuntu cluster. So we have discussed many things in the tech series, and we have a lot of code that has to be deployed to Docker Swarm so that we can set up a production environment where we can serve this over the internet. So in today's session, we'll discuss how to set up Docker Swarm on multi-node Ubuntu servers. And once the Docker Swarm is up, we will deploy the code base as containers in this cluster, and then see how it scales. So at a high level, Docker Swarm implements Raft consensus algorithm. So you could click on this reference and go there. It has a nice interactive way of describing Docker Swarm algorithm. And then this is the official Docker Swarm documentation. So at a high level, I'll discuss how Docker Swarm works, but you could go through these references to get a deeper understanding. So in this data flow diagram, I'll discuss how the Docker Swarm works. So in this session, we have 4 Ubuntu machines, which will work as Docker Swarm managers. It is recommended to have odd number of nodes, but for this video, I have 4 of them. Then in a subsequent video, we'll add another node so that they have 5 nodes as manager. So you need to have an odd number of nodes so that when there is during the election in a Raft consensus, there's something called an election where a leader election happens. So if you have an odd number of nodes, it's easy to break the tie. But if it's an even number of nodes, there's always a possibility of a tie, and then a re-election will happen. So that will duplicate the effort. But if you have an odd number, it's mostly guaranteed to have a result for the leader election. So in the Raft consensus, there are 2 kinds of communication that happens between the manager nodes. One is the election. In the election, the manager nodes participate in the election, and then they decide who is the leader based on the majority votes. So if there is a tie, most probably it happens if there's an even number of nodes, and the re-election will happen, and then they'll try to do a tiebreaker and then try to get the leader elected. Once a leader is elected, then when the client connects to the manager, internally that leader will take the rights to the cluster, and then that manager will distribute the new right to the rest of the cluster. Once the whole cluster accepts the right, then the manager will confirm that the right is complete and then let the client know. So if you have three manager nodes, which is called when an update happens, that log replication will be quicker because there are only 3 nodes. If you have 7 nodes, because 7 is also an odd number, it will take a while for the right to be written to all the manager nodes and get a consensus that the right has been accepted. So there are some other algorithms where you could mention how many managers should confirm the right before right is confirmed back to the writer, the actor in this case. But there are various versions of the Raft consensus. But in Docker Swarm, once the write is done to all the managers, that's when the updates happen to the cluster. So you could go deeper into the Raft consensus, but at the high level, there are 2 types of updates happen to the cluster. One is the leader election, and then the second one is the log replication. And then the managers will deploy the workload to the worker nodes. So the worker nodes are the actual ones who run the container. In our case, we run some containers on the manager nodes too, because they are bigger instances. So the manager nodes will manage the Raft consensus as well as run the workloads. So that way we want to reuse the nodes. So I have the source code where we'll use the shell script to set up the cluster. So I'll quickly go over the shell script today, and then I'll show the output of the shell script. So we first have 4 nodes. We copy the SSH key to the 4 nodes so that we can SSH to them. So when you run this command, it will ask for the root password. So once you provide the root password, the public key of the host from which it is running is copied to the target host. So that way you don't have to do a password based SSH next time. So you first copy the SSH key. Then once the SSH key has been copied, you install Docker on the 4 hosts or any number of hosts. So I wanted to keep the deployment simple, so I'm using shell script, but you could use Ansible or any other automation tools. But I prefer shell script because it's a shell script is available on any Unix machine, so it's quick and easy to port it across machines. So once you have the SSH key copied, then install Docker, and then you add the root to the Docker group so that the root can run the Docker commands. So you're adding here the root user to the Docker group. Then verify that Docker is installed by running Docker ps command, or you can also run Docker hello world container. But in this case, I just ran Docker ps. Then we will add Ubuntu user to the system so that we can avoid using the root user. So we add Ubuntu user. At this point, we might get an error, but you could ignore that because the root user will be added to the system. Here, when we add user, ideally we have to pass the password for the user. Anyway, we're not going to use password authentication, so it will error out because we haven't entered the Ubuntu user password. But that should be okay. As long as the user is added, that's good. So then we'll add passwordless sudo access to the Ubuntu user, and then we will copy the SSH key from the root. This is from the root. So we will copy the root SSH key to the Ubuntu user. Because this has the authorized host entry, we have copied the root SSH to Ubuntu so that we can reuse that SSH key. Or you could just recreate a separate SSH key for the Ubuntu user, whichever way. And then we'll chown the SSH directory to the Ubuntu user and group. Then we will check we are able to access the host using the Ubuntu user without password. We'll just print date on the machines. Then we will disable the password login, and we'll also disable root login so that root cannot SSH into the systems anymore. And this is an optional step. We use AWS Secrets Manager to store secrets. If you are not using AWS Secrets Manager, you could skip all AWS commands. Here we will install a bunch of packages, and then we will install AWS CLI version 2 on all the 4 machines. Then we'll update the log rotate setting so that the container logs are rotated every 1 day. And then we will delete the logs older than one day. So in our systems, we just keep 1 day logs. You can update this 1 to any number of days you prefer. This is to avoid excessive disk usage. Then we will update the 4 hosts to allow traffic from the traffic on the private network. We will enable Ubuntu firewall, allow traffic only on the private network, and will deny any other incoming traffic. So we enable the firewall, and then we'll just display the status. It should show that firewall is up and the traffic is allowed from these private IPs. Then we copy the SSH keys, because these machines are outside the AWS network, so we use SSH keys. If these are on the within the AWS, these are AWS instances, then you could just use the AWS instance role. In our case, they are outside AWS. Then we'll update the hosts file so that they can resolve the host names on the private IP. And once this is updated, the ping should work on this host name instead of the IP address. Then we'll create the Docker swarm. So we'll take the first host. If you are rerunning this command and the Docker swarm is already initialized, then we want to terminate that swarm. So we just run Docker swarm leave force first time. Even though if there's no swarm, it should be okay. Once we destroy the swarm, we will reinit the swarm, and then we'll give the private IP of this host where Docker swarm will advertise itself. So that way the swarm network will only run on the private IP. It's not exposed to the internet. And then once the swarm is initialized, we'll copy the join tokens of manager and worker nodes, worker and manager join tokens to secrets manager. Then on the rest of the hosts, we'll rerun the Docker swarm force, leave force, and then get the manager token. In our case, we want to join the rest of the 4 hosts as the manager. And then we will join the 4 hosts to the swarm, and we'll give the host 1 as the manager where they can get the host 1 is the initial node to which they have to join as a swarm. So once all these rest of the hosts join, these 4 hosts will participate in a Raft consensus. So if you see here, all 4 hosts are in a Raft consensus. All 4 hosts are reachable to each other, and the host 4 in this scenario, host 4 is the leader. So so they internally do the leader election, and the leader keeps shifting among these 4 hosts. At some point, we'll add the 5th host so that we'll have odd number of managers. So I'll switch back to the terminal. And if you see here, we have the 4 hosts participating in the Raft consensus. And also, we are running some Docker containers right now, and these are all the services which are running on the Docker swarm. So at some later point, we'll see how we deployed these containers to the Docker swarm. So with that, I'll conclude today's session. If you have any questions, please reach out in the discussion tab or in the YouTube channel. Thank you for watching.